In the next 5 minutes, we'll build a complete xDaLa workflow end-to-end. We'll pull a ready-made example from GitHub, load it into the XRC-137 Builder, deploy it as a rule contract, then load and deploy an XRC-729 orchestration, start a live session, and monitor the process via listSessions. This example is the API price feed, Coinbase Spot. The point here isn't Oracle hype. It's to show the xDaLa pattern in a clean, auditable way. External data comes in through an API, the node validates it deterministically, the workflow updates its own state, and the orchestration keeps running as a loop. First, open the XGR repository on GitHub and navigate to the API price feed example. You'll find 2 JSON files, the XRC-137 rule JSON, API price feed step Coinbase spot.json, and the XRC-729 orchestration JSON, API price feed loop Coinbase spot.json. Download both because we'll import them directly into the workbench. Now open the xDaLa workbench on XGR testnet and go to the XRC-137 Builder. In the Functions menu, choose Import 137 JSON and select the rule file. The UI populates instantly, and the structure becomes very clear: payload, API call, rules, and outputs. Start with the payload. These fields define the session state that will persist from iteration to iteration. Base and quote define the pair, like BTC and USD. Seek is the iteration counter. Prev price stores the last accepted price. Max delta PCT is the safety guard, the maximum relative change allowed per step. And then you have OK as the success flag plus error for readable failure information. In other words, the payload is your explicit auditable state model. Next, look at the API section. This rule calls the Coinbase Spot endpoint using a template URL. The engine fetches the response, extracts the price value via the configured mapping, and exposes it to the validation logic under a predictable field name. That's the bridge from off-chain data into deterministic on-chain process logic. Now the rules section. This is where the workflow becomes robust. The core checks are simple and practical. If prev price is 0, the first price is accepted as initialization. Otherwise, a delta guard is applied. The difference between fetched price and previous price must stay within max delta PCT. The fetched price must be greater than 0, and the API call itself must have succeeded. That's the essence of xDaLa: deterministic validation over external data plus session state with explicit outcomes. Finally, look at the outputs. There are 2 branches, onValid and onInvalid. OnValid, the rule marks OK true, clears the error, increments seek, and moves prev price forward. OnInvalid, it marks OK false, writes an error message, increments seek as well, and keeps the session alive. Both branches also include a wait_sec delay. For this demo, set wait_sec to something short like 10 seconds, so the loop becomes visible during the recording. Now connect your wallet, make sure you're on XGR testnet, compile the rule, and deploy it. Confirm the transaction in MetaMask, and once deployment completes, copy the XRC-137 contract address. That address is the on-chain reference your orchestration will use. Next, move to the XRC-729 side. Import the orchestration JSON, API price feed loop Coinbase spot.json. You'll see a minimal process graph, a single step, typically called API call step, that references an XRC-137 rule contract. And the key behavior is simple. Regardless of whether the step is valid or invalid, the orchestration spawns the next iteration again. That's how you get a continuous feed without manual intervention. Now replace the placeholder rule address in the orchestration with your deployed XRC-137 address. Deploy the XRC-729 contract and confirm the transaction. Then publish the orchestration JSON on-chain using setOSTC, so the workflow definition is stored and discoverable. At this point, both layers are live. The XRC-137 rule contract defines what must be true, and the XRC-729 orchestration defines how the process runs. Now start the process. Open the session runner, select your XRC-729 orchestration, pick the start step, usually AP call step, and set a safe max total gas for testing. Now click Add to Queue. Then click Start Session. MetaMask will ask you to sign permits. That's expected, because xDaLa treats session control as explicit authorization. Once signed, the session starts and the engine executes the first step. Finally, open listSessions. Click Authorize and Refresh to sign the listing permit and pull the live session state. You'll see your session with its identifiers, its current step, and its status, running or waiting. With WaitSec set to 10 seconds, you'll watch the loop repeat. Fetch, validate, update payload, wait, and run again. That's xDaLa in 5 minutes. Rule, orchestration, session start, and live monitoring. All auditable, all deterministic at the validation layer, and ready to extend into real business workflows. Specs, UI docs, and examples are on XGR.Network.